Navy. Hi, Shakti. Hi, Sriraj. Can you guys hear me? Hello? Can you guys hear me?
We will start within 2 minutes. Thank you. Hello, we will start within 2 minutes. Hi, good morning, good afternoon, good evening. Hello everyone, this is Ravi. I am welcoming you all to the session. We are very pleased to give a warm welcome to all those who have joined us for this event. So before we begin our webinar, let me introduce you to Ledger Technology. It was founded in 2013 with the goal of empowering the next generation with the best opportunities. Let me share with you all in simple words as a company what do we offer. Learning, services, and innovation are three lines of business. In learning, we have Hashcode Junior and Tensor. Hashcode Junior is a platform to familiarize kids of grade 1 to 12 with the coding and technology in a fun and interactive manner. Tensor is a platform to align students and professionals with agile industry requirements and enhance their employability. We provide a wide range of certification program on data science, machine learning, Python, full stack development, database development with various live projects. All our trainees are industry experts with different IT companies. In service front, we have business, talent, and application services. In business services, we provide services like lead generation, digital marketing, handling social media, etc. to our clients. In talent service front, we are responsible for identifying, acquiring, assessing, and hiring candidates to fill open position for our clients. And with our application services, we convert our client ideas to reality. We assist them in customized app and website development. And the final line of business is our innovation center. Here we have an in-house team who are responsible for new research on product and offering. Let's kickstart today's session with a quote. Intelligence is what you have and analytics is what you do with it. I'm very pleased to welcome Mr. Jyoti Ranjan Jati, an expert in data and business analytics field, for our special event today. I am sure we will be enriched by the end of this webinar. So please join me in welcoming Jyoti Ranjan Jati. Jyoti, over to you.
Thanks, Ravi. That was a nice introduction. So, good evening, guys. Good morning. I mean, based on which part of the world you are. Yep. So, before starting, I mean, we all are aware of these buzzwords, right? Artificial intelligence, data science, machine learning. So they're all buzzwords in the market right now. I mean, they have been here for quite some time now, maybe from last 5 years, they have actually gained traction. Okay, but I'm going to throw some more light on these things. Okay, so that you can make use of these things in your future career, and they will definitely help you in your growth. So next 40-45 minutes, we will be talking about Python a bit. Then we'll be talking about machine learning, analytics. Okay, and we will see. I mean, how you can go ahead with these courses if you like these courses. Ravi, next slide, please. Okay, so guys, if I talk about Python, so I mean there are different languages actually which are being used in data science or machine learning. So Python and R, they're actually the most common languages which have been used. Okay, but if I compare these two languages, Python and R, I mean Python is more easy to learn, more easy to understand, and more easy to debug as compared to R. So that's why I mean we are actually sticking to Python in our data science courses. Okay, so if I give you a brief history about Python, it was founded in 1980s by this gentleman Guido. It was done in Netherlands. Then the implementation began in somewhere in 1990s, and Python 3 was released on 3rd of December 2008, and the last version which I checked, as per me, it was 3.9.6. Next slide, please. So this was brief about Python, guys. And if I say why it is easy to use as compared to other languages like Java, I mean, if you see this snippet of code here, just to print a single statement, hello world, I'm using almost 4 to 5 lines, right? But in Python, you just have to write a simple statement, print hello world, and it will give you the output. It's that much easy, guys. So that's why we'll be using Python in our classes, okay? R is bit difficult to interpret, difficult to understand. That's why we will not use R. We'll be making use of Python in our classes. Cool. Next slide, please. And it's not only used in data science, machine learning. It is used in a lot of applications actually. Python, guys. And if I talk about data science or machine learning or AI, I mean, I'm sure you guys must have heard about these words a lot of times, right, in your day-to-day life. So before I actually jump into this topic, can you guys think, what exactly you know about these terms? I mean, have you come across any applications in your day-to-day life where you find the uses of data science or machine learning or AI? So I mean, it will help me understand you better, and so that I can actually take this session ahead. If you can please ping in the chat. Maybe Ravi, you can just put those things in the chat. It will help me understand what people know about data science. I mean, the participants, if they have any prior knowledge about data science, machine learning, AI, anything you know about it, any application which you come across on a day-to-day basis, which you feel might be using data science or ML or AI, anything. Maybe I'll pause for 10-15 seconds so that I can expect the questions to come around. Any questions, guys? Or else I can just proceed. And before proceeding to machine learning and AI, we also have a term called analytics, guys. I mean, it's used rapidly. It's been used widely in a lot many companies. I mean, every single company in this world makes use of analytics. It was not that rampantly used maybe 5 years back, 10 years back. Maybe businesses were not that vocal about growing and all. But now, I mean, the dynamics have changed, okay? Everyone actually wants to rely on data. So if I talk about maybe 20 years back or 30 years back, the data was in the form of maybe paper, right? Everything was in hard copy. There were no soft copies. There were not any databases present which are used in large scale, okay? But now we have a lot of range of databases available. We have SQL databases, we have non-SQL databases, we have MongoDB, a lot of things are there, guys. So everyone is making use of databases to store the data in digital format. And since we have the data in proper format in digital format, we can make use of this data and we can actually go ahead. So what we normally do is we actually make use of this data which is there in digital format, okay, which is there in the databases. We actually define this data, we actually work on this data, and we try to build reports from this data. Okay, let's say I am a data scientist in a company. So I'll not be using this data on my day-to-day basis. Okay, I'll be building algorithms. I'll be building data science algorithms. I'll be building machine learning algorithms. But these things will be used by my seniors, my superiors, maybe. When I say about my seniors, let's say I actually prepare the data. I build a report and I present that report to my company directors. Okay, the people who are actually sitting in my boardrooms. So they will make use of this data actually, the reports, and they can take very important decisions which will help the business to grow. The CXO, the CEOs, the CFOs, they will actually rely on this data. What are the balance sheet? What are the quarterly results? How the company is performing? Where do they want to grow? Are they going to shut down any offices? Are they going to expand? Do they want to grow horizontally? Do they want to grow vertically, the company? So they will rely on a lot of data, guys. This data can be actually provided in the form of reports. That's why we use analytics. Now, if you see this slide, we have basically three types of analytics: okay? Descriptive, predictive, and prescriptive. So if I talk about descriptive analytics, then actually here we talk about the reports and the dashboards. Okay. Different ERPs we have in the market. We have SAP, we have Oracle, and they have their own BI software, guys. SAP has its own BI software. Oracle has its own business intelligence software. They have something called data warehousing, where they dump all the data from all the ongoing and running systems, and they try to build the reports out of it. Okay. But if I talk about reporting tools, data visualization tools, we have two important tools which are very prevalent in the market. They are Power BI and Tableau. So Power BI is basically a Microsoft product, and Tableau is a standalone product. Okay, they are used very, very widely by the organizations. Okay, so basically the business analysts, they will be pulling out the data from different data sources. They'll be refining the data, they'll be cleansing the data, and they will be preparing different kinds of reports. These reports will be used by the board of directors or board members of the company, the senior management of the company. Okay, so that they can take intelligent decisions for the company. Now if I talk about predictive analytics, so what we used to do here is we actually try to predict something. Guys, we use machine learning models here, we use machine learning algorithms here, and we try to predict something. So how the machine learning algorithm works actually, if I give you a brief example. What we do is we feed the machine learning algorithm with lots and lots of data. Okay, then the model gets trained basically. Okay, if X is the input, Y should be the output. If X1 is the input, Y1 should be the output. So we feed lots and lots of records of data to the machine learning algorithm, and the machine gets trained on that. And when we feel that, okay, that machine learning model is behaving properly, it's maybe giving us 80% accuracy, it's giving us 90% accurate results, then based on a business decision, we can actually deploy these models and we can use them in a real life. Okay, this is how things work. But the data scientist or the data analyst has to actually build the machine learning algorithm. And guys, I know a lot of questions might be coming in your mind, and if you ask me, we have people from different backgrounds, right? Not necessarily everyone is aware about computers. Not necessarily everyone is aware of programming, right? So the question which comes to everyone's mind, in fact, it came to my mind also when I started all these things. I mean, can I really do so much of coding? Am I really intelligent enough to do so much of coding? Okay, do I really understand computers better? Is it tough to understand machine learning? Is it an easy language to learn? Is it an easy topic to learn? How is the demand in the market? Will it serve me for next 30, 40 years? So a lot of questions come to our mind, guys. And definitely, I'm sure these questions will also be coming to mind. But yeah, I'll just clear them as we go ahead in this session, okay? So let me be clear to you, let me be frank to you that you don't need to be an expert in coding, okay, to learn machine learning. So there are libraries available in the market. There are Python libraries available in the market. Okay, the market as in the software. Okay, so you have to just make use of these libraries, guys. You just have to call them and use them. There's something called function models, or there's something called libraries. Okay, we just have to use them. The concepts we have to be clear. We should be able to understand, okay, why we are using them. We cannot just pull anything and use it in our algorithms. Okay, but slowly in the classes, we'll be able to understand what kind of libraries we have to use in which kind of situations. Okay, that we'll be covering in our classes, guys. Now, the third one is prescriptive analytics. So based on the output, I can actually prescribe what needs to be done. Okay, so based on the output, the company can take decisions. Okay, what needs to be done to increase the sales, to increase the revenues. Okay, so definitely these things are going to help the board members or the company to function in a better way. Fine. So these are basically three broad categories of analytics, guys. Next slide, please, Ravi. Yeah, I talked about these things. I mean, once you have the data, I mean, data is a huge thing, right, guys? I mean, go back to the previous slide. So data is an ocean, guys. I mean, there are huge volume of data. I mean, if I talk about the amount of data being generated on a daily basis in the whole world, it's in millions of terabytes, guys. It's in millions of terabytes across the whole world. So you can just imagine how much data is getting generated on a daily basis. So if you guys, I mean, people in India, you must be aware that okay, Jio was launched 3-4 years back, right? So they were actually providing services free of cost for the initial 1 year. People were actually wondering, I mean, why a new company is actually providing services free of cost. They're actually, what they're trying to do is they're actually trying to get the data of people. Reliance was actually trying to get a lot of data in their databases so that they can make use of this data in their different businesses. They have Reliance Retail, okay? Reliance, we know about retail stores. We know about Jio. So Reliance can use its data anywhere. Definitely, they will be having the consent of the people, but yeah, they can make use of this data at a lot of places. So I can say data is the gold, guys. Data is the new gold. Okay. So in machine learning, we make use of this data. And I think 3-4 years back or 5 years back, the Harvard Institute, you all must be knowing about Harvard, right? They came up with a statement. What was the statement? So what they said is data science is going to be the sexiest job of 21st century. Okay. So how many years we still have left in 21st century? We have almost 80 years left. So for next 60, 70, 80 years, data science, guys, machine learning, it's going to be the sexiest job. You can just check it in Google. I mean, that was the statement which came from Harvard in maybe 3-4 years or 5 years back. I don't exactly remember the date when it came, but yeah, this was the statement. So that's the importance of analytics. That's the importance of machine learning and AI. See, I know these words might be a bit confusing. Artificial intelligence, data mining, data science, deep learning, machine learning, okay? They're kind of interrelated to each other, but they're not exactly the same, guys, okay? They're kind of interrelated to each other. We will actually come to know about it more in the subsequent slides. Next slide, please, Ravi. Yep, this one. If you see this sphere, so artificial intelligence is the bigger sphere. And inside that, we have this machine learning and deep learning. DL is a deep learning, guys. So they're kind of interrelated to each other, but they are not exactly the same. Okay. So we try to build models. I mean, if I give you examples of AI or ML, guys, we have something called speech recognition. We have something called image processing. You guys must have known about Google Lens, right? Which you have in mobile phones. So what it does, you just feed a picture to it and it just figures out what it is. It actually goes through millions and millions of pictures or figures which is stored in the database. Okay, the algorithms go through that and they try to figure it out. Okay, what exactly it is, and it gives us the output. So everyone uses Google Mail, right, on a day-to-day basis. So when you type something, let's say, "Hi, how are you? I hope everything is fine." You just write 2-3 initial sentences, right? So based on your writing or based on the text which you're putting, Gmail is able to actually prescribe different words to you. Okay? So you don't have to type it anymore. They just prescribe 2-3 words to you, 4-5 words to you based on the context, and you can make use of that. This is all artificial artificial intelligence, guys. Okay, so this is how the systems are becoming more and more intelligent nowadays. Okay, if I give you examples about, so say a lot of things were happening in COVID. Okay, so a lot of people actually they were homestruck. People are not able to go to offices. So we have many companies like Reliance and all. They have their pipelines everywhere. They have this refining setups in Jamnagar, Gujarat. So I was just going through some articles. I found out like how they made use of artificial intelligence to actually monitor these pipelines. So earlier, what used to happen is they used to have a lot of employees who used to manually monitor those pipelines, whether it is getting corroded or not, whether there is any rust or not. But now they are actually making use of artificial intelligence. Okay, so you take any sector, guys. You take any sector. I mean, everyone is using AI and ML these days. You take agriculture industry, you take space, you take education, edutech, you take the financial companies, the fintech companies. Everyone is making use of machine learning algorithms. To talk about stock market trading, share market trading, they are actually what they are using is something called algo trading, algorithmic trading. So the programs have been built in such a way that they actually figure out okay which share to buy at what time, okay, and they will be able to sell it at the best price. Definitely, I mean they are improving day by day. I can't say that okay they are going to predict what is going to happen in the market tomorrow, but they can definitely take intelligent decisions, guys. I'm just giving an example. Okay, you take any machines. I mean, during this pandemic, a lot of people what they did is they bought these robots for cleaning the house. So just switch it on and they just go and clean the house. So they have the maps inside. They have the maps inside them. They just learn on their own. Okay, where is an obstacle in the house, so that they won't go over there again. Okay, they will do the cleaning in the house. They'll do the mopping for you guys. This is just an example. I'm just telling you. I mean, these things are being used very widely in US and Europe. Maybe it's coming to India slowly, but I'm just giving an example how it works. And now if I talk about our cars, our cars are becoming very intelligent day by day. And in Tesla, we all know, I mean, it's going to come to India in 2021, right? They have applied for licenses and all these things. They have opened an office in Bangalore also, the Tesla company. So that is called intelligent driving, guys. Self-driven cars. So how do they work? So it all actually depends on the software. So the machines are becoming intelligent day by day, guys. We're actually trying to feed intelligence into the machines. If you talk about wipers, which we have, so whenever it rains, the wiper actually starts automatically on its own. We don't have to switch it on. A lot of cars have these features. Okay, it's just some examples. I mean, how the machines are becoming intelligent day by day. You can set a timer in your car. I mean, when MG was launched in India, Morrison garages, MG Hector was launched. They have this written on the backside, Internet Inside. So they are becoming so. I mean, machine dependent. It's just not possible to imagine, guys. I mean, we are so much dependent on machines nowadays. It's all because of algorithms. It's all because of data science. So we are feeding intelligence into the machines, and machines are actually trying to behave like human beings. We don't know. I mean, you must have seen a lot of Hollywood movies, right? We don't know. Maybe a time will come when machines will actually overtake human beings. I don't know. You have seen it in Hollywood movies, right? A lot of times. That day is not far off. They're becoming so intelligent. They're making the machines so intelligent, guys. And it's all done through these algorithms. We write programs for this. So all these machines, they have programs behind them. The games which we play in our laptops or in a mobile, so they have all algorithms behind it, right? Anything you take, any banking software, any IT software, anything you take, they have programs behind it. They have algorithms behind it. Okay. If I talk about examples, guys, I mean the whole day is also not enough to talk about. If I start speaking about examples where AI is used, ML is used. If you talk about space exploration, machine learning is being used. If you talk about defense, machine learning is used. Okay, anything. If you talk about agriculture, the tractors, machine learning is used. So my previous company was John Deere, guys. It's a multinational company based out of the US. So they actually build tractors and they build heavy equipments. they are so advanced. They actually make use of all the technologies which are available in the market. They make use of this what do you say? So the Bitcoin technology, what we call it. I am not able to get that word. Bitcoin, or they use this technology, right? They make use of all the technology. They use of machine learning. They make use of data science, everything. So you can actually operate the tractors with the help of your iPads, the help of your mobile phones. Okay, the machines are getting so intelligent day by day. We hardly have to provide any manual intervention, guys. They are using they are being used in this climate control detection. Okay, like the natural calamities which we have, they are widely used in predicting the natural calamities. Okay, so that we can take necessary preventive actions. So just some examples, guys. So if you see this here, AI is the biggest one. AI inside it has ML and deep learning. Okay, they're kind of interrelated to each other, but it's not exactly the same, guys. Analytics is different, machine learning is different, deep learning is different, data science is different, AI is different. We'll be able to cover these things in detail when we actually join the classes. Next slide, please, Ravi. If I talk about the market, guys, so the questions which might be coming to mind, I mean, if I take up this course now, let's say I become a pro in this maybe in 1 year, 2 years, 3 years, once I start working, and what will it be there in the market for next 10 years, 20 years? So if you guys see these figures, the compounded annual growth rate is almost 18% for data science. Okay, and if you see the contribution of these things, speech recognition, video recognition, natural language processing, computer vision platforms, so all these things use data science and machine learning, guys. And you see the market cap of all these applications. So everyone is actually going for these courses. So in colleges and even in engineering colleges, they actually started teaching machine learning and data science in computer science and IT fields. There's so much in demand. So it's never too late to actually get into these fields. Okay, it's been there in the market from last 5-10 years. It's getting more and more traction. It will be very popular for the next 20, 30, 40, 50 years, guys. Data will keep on coming, right? We're not going to, consume all the data, right? We're producing a lot of data every day. So you need reports to actually go to the data. You need algorithms to be fair to the machines. So these things are going to stay at least for next 50 years or 80 years. We don't know what is going to happen after 80 years or 100 years. But yeah, for next 50 years, I can assure you it's going to stay in the market. And it's going to sell like hotcakes in the market, guys. Cool. Next slide, please, Ravi. I'll do one thing, guys. In the meantime, I'll actually try to show you an algorithm, how it looks like. Okay, let me do one thing. I have this thing. So, guys, before actually jumping to this, so if I talk about Python, which you can use for writing the Python code, you can actually download Jupyter Notebook. You can actually download Anaconda. These are all the softwares. There is something called IDLE, Integrated Learning Development Learning Environment. Okay. We have also a lot of things coming from Microsoft, and this one is Google Colab, actually, guys. So this is open source. It's cloud-based, so you don't have to actually install anything in a laptop or a desktop. Just go to Google, search for Google Colab, and it opens up. Let me, if I go to Google Colab, if I just type Google Colab here, let me share my screen. Sorry, I should have shared my screen. Sorry, guys. So Ravi, I'll be sharing my screen for some time. Then I'll ask you to see it again. Okay. So guys, if I just go to Google, I'll just go to Google. Okay. I hope you can see my screen. I try to write Google Colab. So the first link you can click on it, research.google.com. So this is a very good environment which has been provided by Google, free of cost. It's open source. Okay, you don't have to install anything. So if I click on that, I get a lot of things. So I have these algorithms actually in my Google Colab this directory. Okay, so let's say I choose this one, house price. Since this is one example actually, which I wanted to show it to you guys. Okay, so this is how the algorithm looks like. If you see the initial lines, what we're trying to do here is we're actually trying to import the libraries, okay, from the cloud. And we're going to make use of this libraries, guys. Okay, if I actually show you an example how to run an algorithm, let me show the data first. Just a minute, let me show you the data. So this is an Excel sheet, guys. This is a CSV file, comma separated values file. Okay. This example is used a lot many times in the classes. This is one of the caption projects actually, which is very, very popular. So what we're trying to do here is, so as I mentioned earlier, what we try to do in machine learning is we try to feed lots and lots of data to the machine. The machine actually gets trained on the data. Okay. Then we figure out whether we should use the machine learning algorithm or not based on accuracy. So there are different kinds of accuracies, guys. Okay. Different types of models which you have to prepare. Now, if I talk broadly about machine learning, they're actually basically divided into supervised learning and unsupervised learning. What is supervised learning? In supervised learning, we actually want to find the output. We have an output column actually. Okay, we give a lot of input to that algorithm, and we actually try to predict the output from the algorithm. So that is supervised learning. And what is unsupervised learning? In unsupervised learning, we don't have any output column actually in the data. We actually try to find patterns or clusters in the data. Like if I talk about Twitter. So when the US elections were happening between Biden and Trump, so a lot of people used to tweet who is going to win. They used to pass a lot of comments, a lot of tweets in the Twitter. So there were a lot of algorithms which were built to download all the tweets from Twitter using an API. API is basically an application programming interface. Okay, these are available. So you can download all the tweets, and they used to find patterns in the tweets. Okay, we can give actually different colors to the patterns, and we can try to find out if there is any clustering or not. Are the tweets getting divided or not into different clusters? So that is unsupervised learning. So we'll actually go through the details in the classes, but just to give you an intro about supervised and unsupervised learning. So this data set, guys, what I've opened is, it talks about house price prediction. So now every one of us lives in a house, right? So it may be a rented house, it may be our own house, okay? So again, a house price, it depends on a lot of parameters, guys. What is the area of the house? How many bedrooms it has? How many bathrooms it has? Is the house air conditioned or not? Do you have a swimming pool or not in the house? There are a lot of parameters. When was the house built? Is the house old or new? Okay. Any reconstruction happened in the house or not? So a lot of things are there. So what we have done here is we've actually pulled the data, okay, of how many records we have. We have almost 1460 records, guys, here. Okay, the count. So every record belongs to a different house. Every house has different parameter. The area of the house, the year which was built, okay, if it was remodeled or not in any year. So there are a lot of parameters. The bedrooms, the kitchens, the total rooms, okay, garage is there or not. So many things are there. Okay, I'm just trying to show you an example, guys. And in the end, we have the column which is called sale price. So we'll be actually feeding this data to the machine learning algorithm. When we'll build the algorithm, we'll actually feed this data to the algorithm. Okay. So based on this data, the machine will get trained. Okay, if this is the parameter, if this is the value y, if this is 854, then what should be the price? So almost 80-90% of the records will be used for training the model. Then we'll figure out what is the accuracy of the model. Okay. Then we'll decide whether the model has to be used or not. So this is how the data looks like, guys, for example. So in the classes, we'll be actually working on a lot of caption projects, a lot of data sets like this, okay, real-time data sets. So if I take you to the algorithm, I was actually trying to run this. Let me just run this. I've actually put the code over here. I've put the code over here. This is how the code looks like. Now it will not be, it's not possible for me to take you through the code, okay, line by line, because it will take a lot of time. But I'll just try to show you how it works out, how it behaves. So I've run this code basically, the house price prediction. What I'm trying to do is I'm actually trying to predict the house. So I've actually tried to color it actually. Okay. So the predictions are in blue color. Okay. So in the data set, guys, which I showed to you, the predictions are in blue color and the actual house price is in red color. For some records, I've taken 20-30% of records for actually testing my model. So this is how my model looks like. So if I actually try to put the house price, if I try to plot it in a graph, this is how it actually looks like. The blue ones are my predictions and the red ones are my actual house prices. So there is margin of error, right? So our aim should always be to reduce this margin of error, guys. So when we actually get a real life problem when we actually start working in a company, we don't have to build just one model. There are different kinds of models, guys. And there are something called classification models. There are something called regression models. In classification also we have different kinds of varieties like decision tree model, random forest model, naive Bayes model, data boost model. There's so many models, guys. So what a data scientist needs to do is the data scientist actually needs to run multiple models, multiple algorithms, and figure out which model is actually giving you the best output. If I talk about this model, guys, it's giving me 77% accuracy. If you see this, it's giving me 77% accuracy. So now we have to discuss with the business whether this model is acceptable to them or not. Then we can actually provide with this. This is just one example, guys. But when we get a data set to work on, we need to actually run different models. I mean, we have to make use of different algorithms. Okay. Then we need to figure out which one is the best for us. Then that model can be deployed in the real world. So just an example, guys. I mean, it won't be possible for me to explain everything line by line here. We'll be falling short of time. But yeah, this is how it looks like. I'm just trying to figure out. I'm just trying to show you in a graph how the predictions and how the actual values look like based on this model, which has 77% of accuracy. Blue ones are the predictions by the model, and the red ones are the actual house prices. Okay, and you can see there is some variation, there is some difference. Okay, now let me go back to the slide. I actually wanted to show you an algorithm, guys, so I just thought of taking you through an algorithm. Okay, this is done in Google Colab. So in our classes also we'll be making use of Google Colab because you don't have to install anything. You don't have to actually burden your laptop or desktop. It's very easy to use Google Colab. It's cloud based. Just have to go to Chrome and just call it and use it. That's it. Nothing else. Now let me go back to Sriraj. Can you please share your screen? I'll stop my presentation. Ravi, you can share your screen. Sorry. All right, I can share my screen. No worries. Okay, fine. Can you please go to the previous slide? I just forgot what I was talking about. Since I came to the algorithm. Okay, these things we covered, guys. I mean, you can see what's going to be the market revenue of data science. Okay, in next 2-3 years. So compounded annual growth rate is going to be huge. It's almost 18%, more than 18%. Okay, next slide, please. Yeah, we talked about the sectors, right? The sectors which were using this AI.